Bikes, they make me smile.
And it's a rear wheel, so there's the drive side and non-drive side, two different lengths of spokes. There's only 3 millimeters difference between them, being that the drive side is shorter to allow for dish of the wheel. And we have spoke prep, 2 different colors to note the lengths of the spokes. So I'm going to do the blue on the drive side and the tan spoke prep on the non-drive side. So the first step is to lace through the drive side of the hub. We're going to do outies every other hole. So I have just the outies laced on the hub. The initial setup or location of where the hub is in relation to the rim is critical in order to maintain the lacing pattern. If the hub has a logo, it's not critical to the function, but it shows a high level of professionalism when the rim is done. Ideally, when you look through the valve hole of the rim, when the wheel is complete and built, you will see the logo on the hub. In this case, I don't have a logo on the hub, so it's not really an issue. So the first step, to locate the first spoke, we want it to be, since the rim is directional, there's drive side and non-drive drilling on the rim. So I want to make sure that the first spoke that I place through the rim is on the same side of the rim as the flange. So I'm going to drop that spoke through and thread a nipple. And then we will grab the next spoke and simply go over 3 holes to the 4th hole. So we skip 3. 1, 2, 3, and we go to the 4th hole. So for our initial first 8 spokes, we wanted to ensure that we're on the drive side of the hub, flange side, and these are outies, meaning that they were threaded from the inside to the outside of the flange. And then we want to make sure that because it's on the drive side of the hub, that we are now corresponding to the drive side of the rim. It's typical of rims. Some rims are drilled centerline, but for the most part, they're drilled left and right. So the hole, the eyelet hole on the rim, will correspond to one side or other of the rim. So our first hole that we select, our first spoke that we lace, would be the one that's corresponding to the proper side of the rim, right next to the valve hole. And we want to ensure that when the rim is laced, we have a gap here, which you'll notice there's several gaps in a wheel, in a properly built wheel, where the spokes run parallel to each other. So we want to ensure that one of those gaps where the spokes run parallel to each other is on right next to the valve hole, so that when the valve's in there, we can reach in there with a pump. To ensure that that will happen, we want to rotate or preload the spokes by rotating the hub. If we were to rotate it this way, you'd see that I'm going to end up overlapping the valve hole. So I want to rotate away from the valve hole. So now the next set of spokes that I'm doing, I'm going to continue on the drive side, and I will be lacing the innies, meaning that they're going from the outside to the inside of the hub. And we can simply drop those in. When we lift the hub, they should all fall into place. So we have rotated the hub with the spokes, the first set of 8 spokes laced in, and we've rotated away from the valve hole to ensure that when the wheel is complete, that the spokes around the valve hole are a set that are running parallel to each other to allow room for the valve. And so the next step is to continue the innie spokes on the drive side. And so what makes it a free cross is that we're crossing the hub flange, and then we're crossing under one spoke, under another spoke, and then over the final spoke. So it's under, over. And we will continue that pattern. And on the rim side, it's quite easy because we simply go every other hole on the rim, ensuring that we're continuing on one side of the rim where the holes have been drilled. And then we simply continue that pattern by grabbing the next spoke in line. We go under, and over. And with spokes, regardless of the material, feel free to flex them around. You can literally bend them, and once you start truing the wheel, everything will pull into shape. So we go under, over, and then skip a hole. Place a nipple. To kind of verify what you're doing is if you have a built wheel that you can take a good look at before you start building the wheel. And certainly you don't want to start building wheels with a $300 hub and a $60 rim and titanium spokes. It's probably best to practice on an old mountain bike wheel. It's much like grabbing your mom's toaster. You'll want to grab an old wheel and take it apart and lace it up again while looking at another wheel for the pattern. Okay, next spoke, under, over, and then corresponding hole on the rim. And you'll see once you start developing a pattern, it becomes much clearer. If you're working with a deep section rim, such as a Velocity Deep V, you will have to do a little trick in order not to lose nipples inside the rim. Because on the Mavic Open Pro, it's eyeletted, meaning I can't drop a nipple anywhere inside the rim. However, on a deep section rim, there's a hollow place in the rim where you can lose nipples and they'll rattle around, and it's quite a hassle to fish them out. So what we do in that case is we thread a feeder by placing the nipple on a feeder spoke, and then we'll use that as a tool from the outside to thread it on. A lot of rims, and it's a good idea before you start building the rim to shake it around and tap it and get out any shrapnel. It's quite common for rims to be drilled and there'll be little pieces of shrapnel in the rim. So drive side is lace. We'll flip the entire wheel over, and the next step is to lace up non-drive side spokes.